Hey guys, welcome to Unit 15, Lesson 4. Our topic today is use sub with inverse trig functions. So I would highly recommend you writing out all your six inverse trig functions so you have something to look at. And we are going to start with the warm-up. So pause the video and try the warm-up. The warm-up is given to you and it's asking us to find the derivative. So y prime would be the derivative of sine inverse of 2x is, the coefficient stays, it's 1 over square root of 1 minus whatever is inside of arctan squared times the derivative of the inside, which is just 2. I can clean this up a little. This can be 10 over 1 minus 4x squared. The second one, it is saying arctan x cubed over 2. So we are taking the derivative of it. Remember, this is inside. So I can pull out the 1/2. The derivative of arctan is 1 over 1 plus whatever is on the inside squared times the derivative of the inside, which is 3x squared. I can clean this up a little and I get 3x squared over 2 times 1 plus x to the 6th. So in today's lesson, we are going to be working backwards. I'll be giving you something like this and you have to figure out what the answer to it is. So you will be using use sub for something, and maybe you're not using use sub, or you're using a different method of use sub. So let's look at the first one. Usually if we go back to our guidelines that I gave you out on lesson 2, we say that the denominator should be your u. So let's see if it works out. So let's say u equals 1 plus x squared. So what would it be? Du would be 2x dx. So check what you have and what you want to replace with. I want to replace my 2x dx. Do I have 2x dx? Yes, I do. So this kind of worked. So I'm going to rewrite it as, in my numerator, it would be du over 1 plus x squared is just u. So which I can rewrite it as 1 over u du. The integral of 1 over u is ln of u plus c. And now plug back your 1 plus x squared for u, which is 1 plus x squared plus c, and that's your answer. Okay, part B. So here again we have a fraction. So let's pick our denominator to be u. So what happens? It'll be 1 plus 4x squared dx, and I can take the derivative. So it'll be du equals 8x dx. And now let's look at it. What do I have and what I want to replace with? So I have 2 dx. So I can basically divide by 4 and I can get 2. But what about this x? I cannot just introduce x into the question. I can't really do that. So this was not a right form of u sub. So what do I do here? Let's look at the question again. If you look at it from the beginning, you can actually see I can pull out the 2 and I can rewrite it as 1 plus 2x squared, which is of the form, which is actually the derivative of what? Arctan. Right? If you think about it, the derivative of arctan is of x is 1 over 1 plus x squared. Right? Isn't that of this form? So that is why I wrote my 4x squared as 2x. So now what do I pick my u to be? I'm going to pick u to be my 2x. Right? So basically, because it was given 4x, so 4x squared, what would I square to get 2x? So it was 4x, so that is right. So let's do du. This would be, du would be just 2 dx. Now look, what do I have to replace? I have to replace 2dx, which I have 2dx, so I'm good here, right? So let's replace that. So 2dx would be my du. It's 1 over 1 plus 2x to the second. Oh, not 2x to the second, u to the second. So plus u squared. We're writing in terms of u. And now you should immediately be able to recognize this, which we wrote up here, right? This is what? Arctangent of, this was arctangent of x, this would be arctangent of u plus c. And now all you have to do is substitute your u back. Your u was what? 2x plus c. Okay, so again, I've said that in the past to pick your u, see what you have and what you want to replace with. If it's not working out, then you didn't look at the question carefully. You might have to try a different form of u substitution. Okay, now let's look at this question again. So here again, you have to recognize the form, and if you look at this, I can rewrite this as 1 minus 3x squared, right? So square root of 1 minus 3x squared is actually the derivative of arc sine. So I know what my u is going to be. My u is going to be 3x. So my du is going to be what? 3 dx. So look here, what do I have and what I want to replace with? I want to replace my 5 dx. So can I not multiply by 5 on both sides and divide by 3? So if I divide by 3, I'm left with du over 3 dx, right? I need to replace by 5, so I'm going to multiply both sides by 5. So I'm going to replace my 5 dx with 5 du over 3. You could have pulled out the 5 also, and that would be acceptable too. I just wanted to be able to show you another way. So now let's do the replacements. So 5 dx would be, I'm going to pull out the 5 over 3 du over square root of 1 minus u squared, right? So what is 1 over 1, integral of 1 over 1, square root of 1 minus u squared? It is arc sine, so it will be 5 over 3 arc sine of u plus c. So substitute back your u in, which is arc sine of 3x plus c, and that's your answer. Okay, now let's look at this. So again, if you're in doubt that how do I know these are inverse trig functions, look at your denominators, right? They have square roots, and they have, like, the first term is usually 1. It's 1 minus or 1 plus something squared. So these are kind of few tricks that will help you look at recognize the form of the inverse trig functions. But if I look at example 3, my first term is not a 1, but can I make it a 1? I can factor out the 4, I can take the GCF, and I can rewrite it as 4 times 1 minus x squared, right? And if this is multiplication, I can pull out the 4, so square root of 4 is 2, so I can rewrite this as 1/2 1 over square root of 1 minus x squared. And you should be able to recognize this form. You don't even have to do u sub here. You can rewrite it as arc sine, or I can rewrite arc sine like this too, of x plus c. Okay, I want to do actually I would say 2 more questions with you, and then I feel comfortable leaving you to finish up the remaining packet. So here again, I can start with my u as the denominator. If I look at it, recognize the form, right? If I just took my denominator, again, I'm going to show it to you, x to the 4th plus 1. If I do this, up dx, you really have x cubed and you have x, so this would really not work. So be careful. Again, recognize the form, right? If I just rewrite it as x over, remember addition is commutative, 1 plus x to the 4th, which I can actually rewrite as x squared to the 2nd. So that'll help me understand what my u is. So my u is going to be x squared. So my du is going to be 2x dx. Right? So look, what do I have and what I want to replace with? I want to replace my x dx, and I have my x dx. I have that extra 2 in there, so I'm going to divide by 2. So divide by 2. And I'm going to replace that. So I'm going to pull out the 1/2, and this would be 1 over 1 plus u squared and du. Right? And now you recognize this form. 1 over 1 plus u squared is arctan. So 1/2 arctan of u plus c. Substitute. Don't forget to substitute back your u, which is x squared plus. Okay, number 2. So here, this one is a little bit more involved. So here, if you think about, you have arcsine of x in the numerator, and in the denominator you have square root of 1 minus x squared. You know the derivative of arcsine is 1 over square root of 1 minus x squared. So what would you pick your u to be here? Your u is going to be actually arcsine of x. Right? That's why you need to know your inverse trig functions. So du would be what? 1 over square root of 1 minus x squared times the derivative of x, which is just 1 dx. Now look at it. What do I have and what do I want to replace with? I have this, and I want to replace it with the du. So it's going to be basically your arcsine is u, and that would be du. So the integral of u is u squared over 2 plus c. I'm going to substitute back my u, which is arcsine of x squared over 2 plus c. So guys, finish up the remaining of the packet, and if you have any questions, please feel free to reach out. Good luck, guys.